The thrust of this presentation is on plastic waste. So a lot of what you're going to see is not about the science of plastic, but it's about waste and where that takes us. And it turns out that there's a lot of interesting information. When I went looking for material, I found way too much. And so if you don't like what's here, I can give you a list that'll keep you busy for a week. This is, most of what you're going to see are going to be short videos, and I will make commentary on that. So let's have the first one.
George, are you going to be explaining at some point the numbers on the back of plastic items that tie into the recycling program? I mean, I don't have a clue as to what those things mean.
All right. So most of your plastics are coated for recycling. But as it turns out, they're not very useful. And it's more public relations than it actually is helpful. I think from what little I know about that, there's not a lot. What little I know about that is that isn't solving any problems, and it isn't helping the fundamental problem that we face.
I know Lexington says you recycle 1, 2, and 5, if I remember correctly.
I can't answer that question.
Okay.
Earphones.
I can answer a couple of things. Number 1 and number 2 are the polyethylenes. One is low density, one's high density. Garbage bag, grocery bags, you take them back to the store. They supposedly can recycle a certain amount of them, probably 20 to 30% post-consumer. There are uses for HDPE in plastic wood. And again, it's not a lot of it is post-consumer, but some of it is. And the type 6 and type 7 are problematic because 6 is polystyrene. That contains something that damages the ozone layer, or it's manufactured in a way that might. And it's not very recyclable. People are kind of against having that continue. 4 and 5, I don't recall what 4 is, but 5 is generally the kind that is used in food containers. And it's good that they at least try to recycle that. So some of it does end up in post-consumer recycling.
Well, the problem is that everything is plastic. You can't, you look around, there's a candy tray, all right? I was going to show you this a little bit later, but there's a little candy tray. I used to make these things, and we'll get to that in a little bit. The little Dixie cup with your yogurt in it, the handle on your toothbrush. I mean, I don't care where you go. Everything is damn plastic. They're all different, and you can't keep them. You can't keep them separate so that you can recycle them. So when they are in the process, if you're in the factory and you're manufacturing it, then you recycle the material that is production waste. but it's never left the plant. You can regrind it and extrude it again. But once you get it mixed up with the garbage and the aluminum and every other damn thing, it disappears into the waste stream. And as you will see a little bit later, it gets into the waste stream and it doesn't degrade. It continues to fracture into smaller and smaller pieces. These pieces get so small that they get consumed in a large degree in the oceans by fish, turtles, what have you. They get into the food stream, they get into your body, and by God, they get so small in tiny pieces, they actually penetrate your brain and they can cause death. So, and they never degrade. They go on for hundreds of years. I think 400 years is a number that sticks in my mind. So the question is, where do you go with this? What's actually happening? How do you deal with it? And recycling is not enough, but it is the part that is most active. So if you can imagine this, you've heard that China is no longer taking our waste and processing it. But if you go to the Pacific, along the Pacific South Shores, Malaysia, Vietnam, the rest of it, you've got beaches that are actually all plastic. And it's everywhere. There is absolutely no way in hell that we're going to collect all this stuff. And all of your sea animals are eating it and passing it on through the food chain. Let's move on to the next slide. All right, so before we get into the next lap, let me talk a little bit about plastic processes. The one that is most prolific is blow molding, and your milk bottle is a typical product that's blow
It's
molded.
10:30.
In that process, you have you typically start with a piece of just plain tubing, and then that tubing goes into a mold in which air is inserted into the tube, and that pushes that out against the mold. You saw a simple version of that in the first slide. And that gives you a milk bottle or orange juice or all kinds of containers, large and small. And prolific in the food industry, but it's also medical uh, containers or syringes or other things like that. Now you have thermoforming. Now in thermoforming, typically you start with a sheet of plastic. So what you've done is you've used an extruder. You push that through the extruder sort of round and then slid it out into a sheet. You as a second operation, you feed that sheet into a press. The press holds the mold, typically on the top side. That will close, and then you with against a hot mold, and you blow the mold on the bottom of this sheet, and that's how you form that candy tray that we looked at. Now those trays used to be made in Natick. Company called Best Pack that I was in charge of the manufacturing of that operation, and we pumped out tons of that stuff for Schraft over in Cambridge and all of New England. Just a sidekick. If you remember, in the 70s when we had the oil shortage, we had an owner who every time a vendor used to call on us, he would take the vendor out for lunch. Everybody else, the vendor brought lunch. But for us, John took the vendor out. So when that oil shortage came, we happened to have very good relationships, and we never had a shortage of plastic. So we were the best vendor in the country during that particular period of time. Now, and in that plant, we automated the production where previously you would have an operator on the press, female, and they would pick these trays when the trays were stamped, then they were ready to come out of this strip, and the girls would pick them out and stack them. And we designed and built the automated takeoff end of those presses. So we had the most automatic in the country at that time. Now you have rotocasting plastisol. So now you have your plastic with a plastisol as a carrier or solvent, so that it's in liquid form. And again, I was in charge of manufacturing these, in this case in Iowa, for the automobile industry. But with rotocasting, you have a machine that has typically 3 arms. At the end of each arm are a series of molds, and you fill the mold with a certain amount of plastisol. That rotates into an oven, and the mold inside rotates, and it spreads the plastisol against the side of the tooling, and then it cures that way. So when it comes out to the next station, you take that product that you've casted against the inside of the mold, you pull that out, and you have a product. In our case, those were the armrests on your car. They were the headrests on your car. And for that particular point in time, if anybody remembers, they were for horn buttons. And those were the days when General Motors had a patent on a collapsible wheel. And so Ford Motor introduced these huge foam buttons on a steering wheel that had a sort of deep center in it. Now, with accompanying that, you have foam. So your armrest or your headrest or your horn button runs through an oven, maybe 100 moles on a continuous conveyor, and you put the foam in at the top, and that will run across the top. The cover will come down on the mold. That will go over the end and come down underneath, coming back, will be heated, and that will activate the foam, and then it will come up the other end of the conveyor, and the lid will open automatically, and you'll pull an armrest out. It's now a plastisol, cured plastic, with foam in it. You also have foam plastic mattresses. If most of you have mattresses, it's more likely that they're rubber. But on the thinner mattresses, like you have a cushion on a boat, they will be plastic. And then you have injection molding. The thing with injection molding is the tooling is expensive. So that's mostly for long runs, production runs. In our case, we were making steering wheels. We made 90 some percent of all steering wheels in the nation, whether they're on a garden tractor or an airplane or your automobile. And in that case, you're just injecting the plastic through holes in your tooling. And in order to get that right, you've got to be at a certain temperature for your plastic. And if you don't get the temperature right when you're molding it, then the plastic is apt to shrink or distort. And if any of you have a steering wheel that's got a gap in it, and you can see the steel ring inside the wheel, that's because the temperature on the mold, when they molded it, wasn't quite right. You have extrusion. That's pipe or a tubing. Can have a shape for any kind of a product. So let's say spacers, you extruded something that looks like an electrical conduit, and then you just put it in a cutter and chop pieces off. Now you have plastic spacers. If that has a shape, then it's a plastic something else. Um, Now also to come up with some local interest, Boston Woven Hose, otherwise known as American Built Right, in Cambridge, which is a spin-off of MIT from the 1800s. While I was running that from the manufacturing side. We installed the world's largest roller die. So this is an extruder that extrudes extrudes the material into a die that has two drums that rotate. So it comes out of the die and it goes through the drums. In this case, 5 feet wide by an inch thick at 40 feet an hour. Now that's a hot oil extruder. In other words, it's heated with hot oil. That's fed by two 30,000-pound blenders that are mounted on the top of the building. We had roof tanks that are above that. They're fed by the railroad. The railroad car comes in with the plastic granules. You blow it from the tank car up to the roof of the building into the storage tanks. You drop it from the storage tanks into the blenders, where you've got 30,000 pounds in each of two blenders. And then that blends it, and that drops onto the roller, onto the extruder, and then through the, now, our primary product was PVC. And the initial product was sport surfaces. So we made PVC tennis courts. The Winchester Tennis Club was the first indoor plastic tennis court. And that's where it was developed. And it was developed in conjunction with Boston Woven Hose. So that's a first, another first for you in the neighborhood. Now the newest process is 3D printing. And in that, you can get all kinds of shapes. So what is happening there is that although it's not very productive in the sense of a high-speed stamping press or something else, there are all kinds of new materials being developed. And blends of materials, so that is in the labs of all the universities all over the globe, and all kinds of neat new things are happening with uh, plastics or plastic-like materials, and that is where most of the attention is today. This is an effort to clean up the ocean, one of many.
You got to wonder if they've achieved their goal since this was done in 2019. If we've had any of these in the United States and how far they're working along the line to taking care of 1,000 rivers.
I don't know, but I can tell you that my reaction is that that is a lot of effort being put into trying to keep the ocean clear of plastic. And there's not a chance in hell that they're going to get it done. Now, compare this to the effort that we're making on trying to avoid a pandemic. Half the country won't wear a mask. Tell me how much of the country is going to support putting one of these machines at every river opening that we have. And you know that the countries in Malaysia or Africa don't have the resources that we have. I don't see it happening. As important as it is, I don't see it happening.
Unless it can be, George, unless it can be combined with flood barriers, which people are getting very concerned about.
And so, but here's where I think this has to go. The issue that we face, there are several issues, but the primary issue that we're facing, or the most severe, is that plastic keeps breaking, it never goes away, it just keeps breaking into smaller and smaller pieces. So now you're talking about microfibers. And you're talking about microfibers in all the fish in the ocean. Those microfibers are not on the surface. They're in the water and they're on the bottom. And they are so small that they will go through this net. This net's picking up the big stuff and is picking up stuff that would turn into microfiber if it stayed there. But that gets by it turns into microfibers, and it's not going to get picked up. And the only thing that it's going to get picked up by is something that really has a finite filtering capacity. So we are going to have that kind of filtering on every one of our municipal supplies. Every town is going to have to go out to Bedford and make a deal with them to provide them with filtering so that your drinking water gets filtered. And anybody that doesn't have it is going to end up with it in their brains. So what are the solutions? Let's take the next slide. Here we are working on the science working on the material itself. So the answer here is that if you can reclaim it, and if you can't, don't make it. Now, I don't know how far that's going to go. Again, the closer you are to manufacturing, the easier it is to control your product. And water bottles, particularly if you're in, say, New England, where you charge a nickel a bottle and then give you a nickel back, you can collect your material. But nobody's going to collect the toothbrushes and the yogurt container and the disposable spoons and forks. And it's not going to happen. So where do you go with that? Let's see, what's my next slide? Yeah, okay. Just hang on. So it so happens that I have a recent news release, and there's a company, the European Union, has been ahead of the rest of the world for, well, ever since the EU was put together, I guess, on specifications. And it turns out that there is a company in Europe. It's in, well, it's not, it's Czech, Czechoslovakia, I think. But they have what they call EcoCore film. And this is a biodegradable, compostable, static dissipative film technology that is now in use to protect electronics. So when you strip the film from your electronic product and you send it to waste, to a dump, composting facility, it degrades in 3 to 4 months rather than 400 years. Now, that can be, whatever that technology is, I would anticipate it to be expanded to such things as those grocery bags. And if you can throw that grocery bag in your trash and it degrades in 3 to 4 months at the dump, you've solved a big, big problem. So I believe that this channel is the one that's going to be most successful. Because, I think it's a hopeless, I think we have to pursue it, but I think it's a hopeless task to try to get those microfibers out of the ocean. So I'm looking for science as the new handle on this. Now I'm going to take questions now, and I have posted up here the Lexington Waste Challenge. This is a program. This runs for an hour and a half. But this is the program that was put on by the League of Women Voters on Lexington Waste. I don't want to watch it. I'm not suggesting we watch it now. But for those of you who are interested in what Lexington is doing on waste, this was just 2 months ago, and Bob Bodeman, who is in charge of waste in Lexington, and who has been um, awarded the by the state as the #1 recycling expert in Massachusetts, runs our facility. He speaks here for about the first half hour. And if you have an interest in what's happening in this community, then this is how you get to. This is what I recommend that you take a look at. Having said that, what can I tell you that you haven't heard?
I have one question, Charlie. Do you have any, I'm sorry, George, do you have any idea how much plastic is more dense than water and thus sinking in the ocean versus how much is less dense, therefore riding at the top of it for recycling possible or at least recapture?
I do not have that breakdown. I don't know. What I do know is that there is a significant amount on the bottom. And there are products that make their way into the ocean in which there are both the denser and the lighter. There'd be two plastics on one particular item, for example. So that sometimes is eventually it breaks apart, but and the stuff that gets on the bottom is significant, particularly in the Pacific.
I suspect
Nick,
that
I've got
a lot of things filled with air pockets. So even if they were heavier, at least until they break up, they'd float.
Well, that's correct. If it's a bottle that's got the cap on it, but typically that's not what happens.
Yeah, along that same line, it's not just the nature, the chemical nature of the material, such as PVC or versus polyethylene, but it's the outcome of the manufacturing process that can affect the density. So presumably you could have a less dense product out of the same material, but it's not clear that it would be as useful. It might be.
Now, that's part of the problem is that you're not talking about one product here. You're talking about a whole product range, shapes, sizes, materials.
Yeah, well, what I'm saying, yeah, you're right. But what I'm referring to very specifically is if you put a number,
Yep.
like 1 or 2 or whatever, that only has to do with the chemical constitution. The
Yeah,
manufacturing process will also affect the density because this is a polymer. It's a polymer. Many, many strands of material that have been folded together or pressed together, just as George was describing, that sort of thing.
Hey, George, a different question, or a question that's related. In the temple, we used to have plastic silverware, knives and forks and stuff for functions,
right.
and we use paper plates. Before the virus hit and we had to close down, we converted over to something I was told was cornstarch based, used for utensils, and I think something in the paper for the, or maybe there was just no plastic coating on the paper, something like that as well. Do you know anything about the use of cornstarch in terms of molded plastic, as a replacement for molded plastic shapes?
I don't. Um, I do know that corn is being used in various ways, but I'm not knowledgeable about this specific application. But the
And the key is we were composting the cornstarch based stuff. So I know Black Earth was taking it.
that leads me to another question. Let's suppose, for example, that cornstarch turns out to be the answer. I think we've diverted something like 20% of the corn growth to petroleum for vehicles. Somewhere along the line, we got to decide whether we're going to feed the people or feed the car. So if it's corn and we have a warming planet and we're losing our acreage for growing food, it's going to be another serious discussion.
Well, that leads me to something that since you said that, I just had a premonition. I think I'm going to sell my GameStop stock and buy Arthur Daniels Midland and see what goes on.
Well, there's the very old problem. It doesn't make any difference if you're right unless you get the time frame correct.
For sure.
One thing about the cornstarch situation, I'm pretty sure the cornstarch itself does not come from corn. It comes from the stalks. So you got two products that you're getting from one plant, I believe, in this situation. So to me, what we have here is two things. One is that plastics are made chemically and they can be degraded chemically. So whatever you do chemically, you can make it and degrade it. You can use biological organisms to do that. Perhaps that's been research being undergone. I'm trying to answer Charlie's question about that. There's research being done on that. It has been done for 50 years or more. It's just not very far along. It's very difficult to get the chemistry proper to particularly to degrade plastics. And some of the polyvinyls, some of the other plastics that are very hard to degrade chemically, if you look at the chemical reactions. But that's going on. But the other side of this, I think, and actually I think to George's point, is what it takes is looking at the problems from an economic and policy standpoint, policy being politics to a great extent. You got to convince people that you've got a problem. You got to be able to figure out how to solve it. What's the most economic way to solve it, perhaps, so that you can sell the idea to the consumers. And I think that's that's where we lie. I don't have a problem with trying to figure out what to do with all the plastic. Trying to collect it that's already been in the oceans. Yeah, that to me is a big thing. And the fact that it's getting into our food chain, that's a big problem, but it's not unsolvable, I don't think.
Where the European Union has a leg up is that they have consistently over the last, 50 years, passed legislation that made this sort of thing happen. If we stick with a program that's strictly economic, then we're always deep in the quagmire before we try to get out. But if we go with the European Union's method, then we get some legislation in place and we do something like taxing production that's petroleum based, but not, and then use those revenues to support processes that are not petroleum based. Or, you see what I mean? And, so you create the economics artificially, yes, but you create them for the better good. And the other thing that the economic union has in place or had in place, I haven't done anything with it recently, but you are responsible if you produce a product. Some of their laws require that you take care of the waste. So if you produce a battery, you have to accept the dead battery back and reprocess it yourself. Now, I don't know how much of that's in place today, but the concept was there and has been there for a long time. So if you think of it that way, when you produce something, you pay a tax, and that tax money, you get your money. It's like the bottle. When you return
It's
it, you get your
11:30.
nickel back. So those kinds of tactics, I think, need to be part of the solution. I'm not sure exactly where, but somewhere in it.
Well, it's like the carbon tax, George. You know, it's not too popular and it's not gonna happen. People just don't understand, why they're paying for stuff. You get enough pushback on the bottle bill for the deposit. Never mind taxes on things that aren't recyclable.
So you
It's just
have
a-
to,
George, you inadvertently used a loaded word in your description there, and that was artificial, about artificially taxing certain sorts of things. And this addresses Peter's comment also in a way, although it's a hard sell, and that is to talk about the real price of something. That the real price of our goods involves getting rid of them. And if, at least in principle, you ought to be able to tax something so that its real price includes the recycling or the disposal or whatever else. And even the playing field that way. Right now, an awful lot of products basically get a free ride because they're dumped on everybody else, and our tax system, let's say our landfills and stuff like that, is what's paying for them. And so we're really subsidizing certain kinds of products.
Well, you can start with petroleum and go downhill from there, Mike.
Absolutely.
I just want to say, George, this was an absolutely fascinating talk.